So, how did you like the last winter? Did you make a lot of snowmen? Or maybe even build an igloo? Chances are you did not even get the chance to do so. This is because in the past 60 years, the average winter temperatures have been getting warmer and warmer as a result of climate change. For us humans, that might be nice, since we have lower heating costs. But for the animal kingdom, this can be more difficult to deal with. Since animals do not have the privilege to go inside a house and turn up the heat, they have to develop their own strategies to deal with these frigid winter temperatures. And they did.
Take for example amphibians, such as newts and toads. To deal with the cooler temperatures of winter, they look for a place with constant temperatures to hibernate there. Here we do distinguish two main strategies. Some of them bury themselves into the ground to benefit from the warmth of the earth. Others go to the bottom of water bodies, where the temperature remains more or less constant. Due to their very thin permeable skin, they are able to absorb oxygen from the water. On the land, however, this does have the disadvantage that they are vulnerable to dehydration. Probably the amphibians are more vulnerable to the effects of climate change than we are.
Because these animals are cold-blooded, a warmer winter might seem like it would be beneficial to them. That does, however, not need to be the case. There have been multiple studies that report a negative effect of warmer winters on the fecundity and overall health of amphibians. But how can this be? Because they are ectothermic, the activity of their bodily functions is related to their surrounding temperature. This means that when the winter is warmer, their bodies are more active and they therefore use more of their stored energy. On the other hand, a different experimental study has found a positive effect of higher winter temperatures and a shorter hibernation period. They found that the survival rate and the change in body mass after hibernation of the common toad were better for the toads that were put through a simulated climate change, so that experienced a warmer and a shorter winter.
Moreover, a lot of amphibians start the reproductive season right after hibernation. To kickstart the reproductive organs, they use energy stored from last year. If they have less energy left, however, this can result in a lower fecundity and a lower reproductive output. On the other hand, warmer winters also cause the reproductive season to begin earlier, so the effects of the energy loss during hibernation will be less.
The higher temperatures and milder winters, because of climate change, also allow some amphibians to expand their range further north. Although this is obviously positive for amphibian species in question, the overall effect does not necessarily have to be favorable, since invasive species can outcompete other amphibian species. An example of this is the Cuban tree frog, which outcompetes other tree frogs. The total effect therefore strongly depends on the community.
Climate change further affects precipitation as well, making the warmer winters also wetter winters. This extra water also has a negative impact on the total amphibian survivability. Some studies have found that for terrestrially hibernating amphibians, the excess rain negatively affects the number of survivors at the end of winter. This is most likely due to the soil becoming saturated and the amphibians having to stop using their lungs for breathing and to rely solely on their skin diffusion.
Another negative climate impact due to the change in surrounding temperature is the amphibian's immune system functioning. An example for this is one of the most famous examples of amphibian decline, the golden toad. Whereas the exact mechanisms are not completely clear, it is known that one of the main drivers of the extinction of this species is a fungal infection. The changes in temperature brought on by climate change are seen as likely hypothesis for the decrease in immune system function and a subsequent decline of the population health. There are some doubts about this hypothesis, since some experimental studies found some conflicting information. Toads were more easily infected after a shorter and warmer hibernation, but the infection spread more rapidly in individuals that had a longer and cooler hibernation.
In summary, although warmer winters and climate change pose a multitude of negative effects, there are positive effects to be found too. Whether these effects are positive or negative is dependent on the surrounding environment. These different effects may sometimes even conflict, but that just goes to show that the exact effects of climate change and warmer winters on amphibians are not completely known or set in stone.